Have you ever been out on a run using an app like Strava and wondered, what does it actually take to build something like this? I mean, we're not just talking about a simple little tracker. We're talking about a global platform that has to handle millions of people, all running, biking, and hiking at the exact same time. So today, let's pull back the curtain and design one of these massive systems, right from scratch.
And this is really the heart of the problem, right? 10 million concurrent activities. I mean, that's a huge number. It immediately tells you that a simple app with a basic database just isn't going to cut it. You've got to think about everything. What if the network drops? How are you going to store all that data? And how do you make it all feel fast and responsive? It's a massive engineering challenge.
So here's our game plan. First, we'll set up the challenge and define our blueprint. Then, we'll lay a really simple foundation, just the core building blocks. After that, we'll tackle the two biggest hurdles, making it work offline and designing it for that massive scale. And to wrap it all up, we'll add a cool finishing touch, real-time sharing. All right, first things first. Before you write a single line of code, you have to establish the blueprint. This is where good engineers define the rules of the game. We have to ask, what exactly does this app need to do? And maybe more importantly, what are the big constraints we have to work within? A good way to think about this is separating what the app does from how well it needs to do it. The what is the functional side. You know, start, stop, save an activity. Pretty straightforward stuff. But the how well, the non-functional side, that's where the real fun begins. High availability means it can't just go down. It absolutely has to work without a network connection. And of course, it's got to handle those 10 million concurrent users. These are the rules that will shape every single decision we make from here on out. Okay, so with our rules in place, let's start building. We're going to start with the simplest possible version of this system. We're not going to worry about scale or offline mode just yet. Right now, all we need to do is figure out what data we're storing and create the basic ways for the app to manage it. At the heart of pretty much any application is its data. For us, it really boils down to these four things. You have a user, that's you, the athlete. That user performs an activity, like a run or a bike ride. Every activity has a route, which is really just a long list of GPS points. And finally, users can be connected as friends, so you can see what they're up to. This simple model is the backbone for everything else. So how does the app on your phone actually talk to our servers back in the cloud? Well, it uses something called an API. And the very first thing we need is a way for the app to shout, "Hey, a new run is starting over here." This is done with what's called a post request. Think of it as the digital starting gun for the workout. And check this out. This is basically all the information the app needs to send. It's super simple. It's just a tiny little piece of data telling the server, hey, the activity we're creating is a run. That's it. That's all the server needs to know to get a new activity record set up in the database. Of course, once you start a run, you might pause it for a traffic light or, eventually finish it. So we need a way to update the activity's status. For that, we use something called a patch request. Now, this is important because it lets us change just one little piece of information, like changing the state from in progress to paused, without having to send all the activity data back and forth. It's a small detail, but a really important one for efficiency. And this is the crucial update. When you finally hit that save button on your phone, the app sends this one little command. Setting that state to complete is the trigger that tells our whole backend system, okay, this workout is done. It's time to process the data, finalize everything, and get it ready to share with friends. So let's put that all together. Here's our super simple initial design. The user starts a run on the app. The app sends that post request to our activity service, which is kind of like the brain of our operation. And that service then creates a new entry in our database. Simple, clean, and it works perfectly, as long as you have a flawless internet connection. But what happens when you run through a tunnel? And that brings us to our first huge hurdle, offline mode. Think about it. You're on a beautiful mountain trail miles from the nearest cell tower. With our current design, the app would just completely fall apart. This isn't a nice-to-have feature. This is a non-functional requirement we absolutely have to solve. The solution to this comes from a really important shift in thinking. So often we think of the big servers as doing all the heavy lifting, but we have to remember that modern smartphones are literal supercomputers that we carry around in our pockets. The key is to stop treating the phone like a dumb screen and start treating it as an active, powerful participant in the system.
And as soon as you make that mental switch, look at all the problems that just melt away. Boom, network issues? Gone. You're not dependent on a connection anymore. We're saving a ton of bandwidth because we're not pinging a server every second. The user gets instant, up-to-date stats right on their screen, and this is a huge one for us engineers. We've radically simplified the amount of work our backend has to do. It's a massive win.
So here's how that works in practice. As you run, the app collects all those GPS points in memory. Now, just in case the app crashes or your battery dies, it saves that data to your phone storage every 10 seconds or so, kind of like a little insurance policy. Then, once you're done and you're back online, the app uploads all that data in one big, efficient package. And only after the server says, "Yep, got it," does the app delete the local copy. It's a really robust and resilient way to do it.
Okay, hurdle 1 cleared. We've solved for offline mode. But now we have to face that other monster requirement we talked about: massive scale. Even with our clever offline design, all that data eventually gets uploaded. And we have to process and store millions of these activities every single day.
So just to put this problem into perspective, get ready for this number. With some back-of-the-napkin math, we're looking at storing over 0.5 petabyte of data every single year. That is a mind-boggling amount of information that our system needs to be able to handle gracefully. And you might be wondering, where in the world is all that data coming from? Well, this table breaks it down. The basic info about the run, the metadata, that's tiny, basically nothing. But the route data, the actual collection of GPS coordinates, oh boy, that's the real killer. For just an average 30-minute run, that's about 15 kilobytes. Now multiply that by millions of users doing billions of activities, and suddenly you're at 0.5 petabyte a year. So how on earth do you manage this? You definitely can't just throw it all into one giant database. It would literally collapse. You need a multi-part strategy. First, we use something called sharding. This is like taking a giant library and splitting it up by year, since people are most likely to look at recent books. Second, we use data tiering. This is just like your closet. You keep your daily clothes up front where they're easy to get, and your old stuff gets moved to a box in the attic. We put fresh, hot data on fast storage and move old, cold data to cheaper archival storage. And finally, we add a caching layer. This is like keeping your favorite book on your nightstand, so you don't have to go back to the library every time. It keeps popular activities in memory for lightning-fast access.
All right, we are in great shape. We have a system that's tough, it can work offline, and it can scale to handle tons of data. So now let's add the final bit of polish: real-time sharing. This is that awesome feature where your friends can follow your progress live on a map. It's a fantastic feature, but it actually creates a brand new puzzle for us to solve.
And here's the puzzle. Our brilliant offline first design means the server has no idea where you are moment to moment. It's totally blind until you finish your run and upload the data. So if the server doesn't have the data, how can it possibly share your location with your friends in real time? It feels like we might have just designed ourselves into a corner. We need to bring back some communication, but we have to do it really intelligently. Now, when engineers hear real-time, our brains often jump to really complex solutions like WebSockets, which create this constant open connection. But that's kind of like using a sledgehammer to crack a nut here. It's total over-engineering. A much, much simpler approach called polling is actually way better. The key insight is that the user doesn't need perfect, up-to-the-millisecond data. A delay of a few seconds is totally fine, and it won't hurt the experience at all. And this polling solution is just beautifully simple. Here's how it works. If and only if the athlete turns on live sharing, their app will send a tiny little location update to the server every few seconds. Then, any friend who is watching simply has their app ask the server, "Hey, what's the latest location?" every 2 to 5 seconds. That's it. It's simple, it's easy to scale, and it gives the user the feeling of a perfect live stream without all the crazy back-end complexity. So, there you have it. We've gone from a simple idea to a really robust system that can handle millions of users, work flawlessly offline, and even support cool real-time features. We've built an incredibly powerful foundation. And that brings us to the final question, and this one's for you to think about. With this powerful architecture in place, what killer feature would you build next?